I think it's about time. Welcome back to these new lectures, the lecture of Foundations of Computing. Today, we will have first an overview on Project 2, which will be given by Han, that you might already know. They have been one of our head tutors for many years, and they're going to explain a little bit what the project is about. Han.
Thanks. So I know that Project 1 is still probably on your minds right now, but this is just a brief overview and introduction to what you'll be tackling next with Project 2. This is just an overview. Please refer to the Canvas assignment page and the project specification in Grok for the full details, and those will be the most up-to-date. So for context of this assignment, it's based around RPG battle systems. And so it's inspired by a genre of video games where players choose actions that their characters take in a turn-based battle. Some examples include the battle systems in Super Mario RPG, Pokemon, Final Fantasy, and tabletop games like Dungeons and Dragons. The characters will have various stats like health or HP, that'll decrease when the opponent's characters successfully attack. During a player's turn, they pick actions for their characters, and the player needs to consider strategy. Some actions will be more efficient or more effective than others in different situations. Some games have special action types that use magic or some other special resource. In this one, it'll be electricity. Many games have an item system where the player can choose to use an item that they have obtained that will have some special effects. In Comp RPG game, your player will have a team of 5 characters, and at most 2 of which will be actively fighting for your side. So you'll start with 2, and then you might have a character get defeated. And if both your active characters get defeated, then your opponent has won. Each character has its own attack and defend moves, so it's important to select or swap during battle to form a suitable pair to face your opponent's pair. For each turn, you'll decide on at most 1 action for each of the 2 active characters. This action might be to attack using one of your character's attack moves, or to defend using a defense move, or to use an item, or to swap to make a different character from your team active. Your opponent will also choose actions for their own active characters. Your characters will have some stats that begin the match as full and will be affected by the actions that you and your opponent take. One of these is health, which is individual for each character and can be lowered by things such as your opponent's attack moves or move backfiring. The other is electricity, which is used up by choosing actions that have an electricity cost and is shared amongst your team. So the format of the actions in this project will be, each action will be a tuple, and an action can be an attack or defend using an item, swapping for another character. They're represented as tuples, but they can be different lengths depending on what the action type is. So the first 2 elements of the tuple are the name of the character performing the action and the action type. And each action type has specific elements that will be included. So here are some examples. With action 1, we have Network Ninja performing an attack that's a DDoS attack on Python Pal with inflicting 3 damage to a single opponent, and it costs 1 electricity. So that's what those numbers and strings mean in that first action there. Action 2, HTML Hero, using a defend action called Firewall, which can give 2 protection and is free, so it has 0 electricity that it uses. Python Pal using an item, and that's the debugging tool. This action 4 is HTML Hero swapping out with Binary Bot. You'll also be using objects from predefined game and player classes in the task for this project. You'll have full access to the source code to these classes. So you'll be mainly using objects from the classes, not having to define your own classes or anything. However, if you do want to add methods to it to organize your code, then feel free to do so, as long as the required features of these objects are kept maintained. That in each of your program.py files, you'll see some import statements that are importing the data, which is some lists of dictionaries with quite complex data structures in them, which has the information for what the different kinds of characters are and what their skills and effects are. We also have the classes here, the player and game, and you'll need this import statement in your program.py file in order to be able to use those classes. So don't delete that line, it's there for a reason. But if you do delete it, you can revert back to the original to get back what you need here. The player objects, they have quite a few things in them. And so the reason that we're using classes here is because we have a state that we want to keep the information of, and having a class that has these attributes is a really good way of keeping track of the different values within our game. So we've got a player object, and it'll have a player ID, which is an integer, a list of dictionaries for the characters, and money, which will be an int, electricity, which will be an int as well, active characters, which is optionally given when you create a player object, but will be a list of strings, the items, which is also optionally given, in that you can construct or you can create a player object without having to pass in this, this information, but you can also pass in this information if you want the player to have those things. And if you don't pass some things in, it will automatically select some, like randomize some of the information. So have a look through the source code to see how these things are initialized. And we also have the number currently active, which is also optionally passed in, and that's also an int. Within Python, it will look like this, in that this is a representation of the player object. So it does look like it has a whole lot of information in it, but you can access the different parts of this information by using the dot and then the attribute name. So you might do player, or you might have a player object stored in a player1 variable, and you might go player1 dot characters, and you would get that attribute that's stored for that player. And the way that you can define a player, like my player here, is by calling the player class and passing in these other objects. A game consists of a list of player objects. So in the previous slide, you saw the player object. The game will have these objects in a list as one of its own attributes. It'll also have the turn and a history, which is a list of tuple actions. The games, when you sort of print them out and see how they are represented in Python, are very, very long, and it wouldn't fit on the page. But I encourage you to have a look at how it's represented when you have access to the assignment. But to construct a game, if you have the list of players, you can pass it in, and the turn and the history, you can pass it in and create a game object that way. There's more information about classes and objects in the assignment spec. And I encourage you to have a read through that if you haven't seen many classes and objects before. So the tasks in this assignment, you'll be using some of the objects and different things like the history to process some of the information. For the first task, you'll be just focusing on that history list, so the lists of tuples that are the actions, and calculating some information based on that history, and producing a CSV file from that information. So for task one, you'll probably want to brush up on CSVs and look at some of the worksheets that cover CSVs. For task two, you'll be loading in a saved game state from a file. So for this one, you'll be wanting to refresh your knowledge of opening up files and reading in files. Yeah, did you have a question?
I was going to say, isn't the .csv file type usually used for Excel, or is it?
So CSV is a really common file type. It's comma-separated values. It is used for Excel. That Excel has a way of opening them up. However, its usage is much more broader as it's quite a basic file type. Yeah, you could, once you've created this CSV file, you could download the CSV file you've created and open it up in Excel, and you'd be able to view it as sort of a spreadsheet there. Yes, with task 2, you'll be sort of loading up in a saved game state from a file. That'll also involve constructing that game class or game object. So sort of getting all the information out from the file and getting the different things you need to pass into the game constructor to make a game object. Task 3, you'll be checking whether an action list is valid given the state of the game. So you'll be given a game object that has the current state of the game. You'll be given the actions, like a list of actions. So this will just have up to 2 actions in it that will be a particular player's actions for that turn, and you'll be checking whether or not those actions are valid given the current state of the game. So you don't need to check the whole game state for this one, just that the actions are valid and following the rules of the game within the current game state. In task 4, you'll be doing some image manipulation to create stats bars for the game. So if you remember the stat bars here, you'll be creating this sort of thing using the Pillow Python image library. So for that one, you'll probably want to review the worksheet in Grok that is on image manipulation. For task 5, so task 5 is creating the agent that will actually play the game. So you'll be creating a function that's like play comp RPG that'll take some limited information. So it'll have a player object, and it'll have the current turn that you're on, and it'll have your opponent's active characters as a list of strings, and it'll also have the history of the game. And you'll be making a decision on what your actions are based on that information, and that function will be returning the actions that your player agent would want to play within that turn. And that will also involve a tournament, is the intention for that one. So you'll be playing against other agents and sort of trying to think about your strategy, what actions make sense at different situations and game states that your player might find themselves in. Some tips for success for this project. Start as soon as you can. That you'll probably be quite busy at this point in the semester, but I really encourage you to have a look at these questions as soon as you can, even just to work out what you need to revise or like the worksheets that you might need to do before starting on it in order for it to have that background knowledge for the assignment. Remember that what you submit must be your own work. Check out the marking criteria that'll be in the rubric in Grok to make sure that you're sort of, meeting the approach and the code style and the commenting and those sorts of things, as well as the test case correctness. Read the question description carefully. You can attempt them out of the given order. So you might find if you're stuck on one that you move on to the next, because some of those tasks don't rely on the previous one to start the next one. The only exception with that is you might want to do task 3 before doing task 5, if you want to be able to sort of validate that the actions that you are trying to perform are valid. Ask questions to clarify the instructions on the Ed discussion forums. There may be things that we've missed out in the specifications, so feel free to ask those questions on Ed. And if it's a general question, having it public is great because then other people can see the question and they might have been wondering the same thing. So if it isn't something specific about your own code, then it's sort of a more general question where you're not having to share any of your code to ask the question, then publicly is great. Remember, you can submit as many times as you want, and so keep submitting frequently so you don't forget to submit right at the end, and also because it'll run those test cases against it, so you'll be able to see how your code performs against the examples and hidden tests. But also remember there are assess test cases. For some questions, quite a lot of assess test cases. So you'll need to make sure that you thoroughly test your code. Don't just rely on looking at the green diamond and being like, oh, it's green, I've done it, I can sort of walk away now. It is possible to pass all of the examples and hidden test cases that are shown, that you see the outcome of, but then still have some assess test cases that are not correct. So do your own thorough testing of your code, and try and debug that as much as you can. And you'll also be matched on approach, code style, and commenting. So thanks for listening, and the project will be released on Monday, the 16th. So look out for it then. Thanks.